Welcome everyone to the US Web Design System monthly call for April 2024. This month we're celebrating the budding leaves and spectacular flowers of spring with shades of pink and green and blue in the USWDS logo. Slide 2. My name is Dan Williams, he, him, and I'm the USWDS project lead. And here on screen is my avatar. Dark hair, blue sweater, collared shirt. Today, my physical self is wearing a simple green checked shirt. It's also Bright Green Socks Day. As Jeannie mentioned, we are recording this call, and I'm happy to say we've started to be able to share the recordings of these monthly calls publicly. You can find pretty much everything from the last year's worth of monthly calls back to January 2023 on our website at designsystem.digital.gov/about/monthly-calls. We typically post videos shortly after the monthly call, and we also link out to the slides and script hosted at Digitalgov. We've posted a link to our monthly call page in the chat. We'll be posting other links and references into the chat as we go along, and I encourage you to ask questions in the chat at any time. If any member of our team can answer your question in the chat, we'll do so. Otherwise, there'll be some time for questions and answers at the end of the hour. Also, be sure to introduce yourself in the chat as well. It's nice to know who's here, and it's good to have you here today. For those of you who find the chat distracting, you're welcome to close or hide the chat window during the main presentation. You can reopen it later during the Q&A session at the end of this call. So thanks. And with that, let's get started with slide 3. So what's our agenda for today? Well, first we've got a nice site launch, and then a few quick product updates. And then we'll spend the rest of the time with an introduction to something we think is super important to the future of the design system, something called web components. And then hopefully we'll have plenty of time for Q&A. Slide 4, so let's get into it with new site launches. Slide 5. Today we're looking at beta.notify.gov. This is the beta site for a new service from TTS here at GSA, notify.gov. Notify.gov is a text message service that helps federal, state, local, tribal, and territorial governments more effectively communicate with the people they serve. It's currently in a select pilot program. On the notify.gov homepage, we see a simple and direct bell icon with a bright red notification dot. The hero area is bold and blue with an illustration of a mobile device receiving a text message and the words, "Reach people where they are with government-powered text messages." Slide 6. So congratulations and great work. Be sure to let our team know when a new site launches, either with an email or a note on the USWDS public Slack channel. Slide 7. So now for a few product updates. Slide 8. First, a number of research updates. We've put a bunch of effort into operationalizing usability research over the last year, and it's really starting to come together. Last month, we performed some usability research focused on 5 components: banner, site alert, memorable date, time picker, and radio button. Slide 9. We've been continuing our focus on research with people with disabilities and users of assistive technology. In this last round, we had 5 users with visual impairments, 3 blind and 2 low vision, 1 user with a motor impairment, and 2 users with mental health conditions, ADHD, anxiety, and depression. Slide 10. We were also able to test on a broad range of devices and user agents, 4 screen readers, 1 instance of screen magnification, and tests on both mobile and desktop. Slide 11. We'll have more to come on findings from this last round of research, but we learn a lot with every round, and we're gearing up for the next ones now. Slide 12. Next, a quick update on component discussions. We're adding a link to our new component proposal discussion board in the chat. That's github.com/uswds/discussion/categories/component proposals, where we're working to solicit discussion on components teams hope to see in the design system. We've got 10 active discussions right now, but there's always room for more. We've got common feedback, CUI banner, glossary, spinner, tabs, toast, toggle, quote with attribution, skip to, and sidebar primary navigation. We're also getting ready to get the tabs discussion into the formal proposal phase, converting the information we've gathered in the discussion into a formal proposal. When we've finished, we'll post an update into the tabs discussion and ask any follow-up questions we have in there as well. And we'll be talking more about component proposals and evaluation in the coming months. Slide 13. And finally, I'd like to point to a couple other discussions on the boards right now. We've had some interesting conversation around the idea of like dull colors, or what we might think of as the calm equivalent of the vivid color variations we currently support. It's a good and interesting proposal, and it's a thoughtful look at how we might provide an even fuller gamut of color token options. There are also a couple other accessibility-related discussions that might be of interest. This month is recognized as National Stress Awareness Month, and we're wondering how teams think about designing with stress in mind, and also how we might think about usability research that gives insight into usability under conditions of stress. There are also a couple other accessibility-related discussions on WCAG 2.2 and the overlap between content and WCAG. So check out these discussions and jump in if you have something to contribute. And that's it for product updates. And slide 14. So this month, we're going to give an introduction to a technology that we think is going to be really meaningful for the design system. And has the potential to have a big impact on how we build with the design system, how we design with the design system, and how teams stay up to date with the design system. And that's something called web components. Today, we'll talk about what this technology is and why we care so much without getting too technical. We'll be talking about this a bunch more over the foreseeable future, and this is just the start. Slide 15. So have you ever viewed source on a website? You can do this for anything you can open in a web browser. There isn't really much reason to do it. There are other ways to interact with the underlying code of a web page if you're a developer. But if you're a certain age, and that age is close to mine, somewhere in the vicinity of 50, there was something of a perverse charm in knowing that you can look under the hood of any page you visit on the web and see some of what makes it tick. Because, back when the web was young, this was one of the best ways to learn how the web worked. And it's still sort of gratifying to know that you can peel the lid off even the most sophisticated of sites and look down kind of right into its guts. Slide 16. And when you do, you'll see something kind of like what's on this slide. Here we've peeled the lid off the USWDS homepage, the homepage that you see over there on one side of the screen. And underneath is a bunch of code like what we see on the right side of the screen in gold, like this monospaced, codey stuff, things that look like a computer is writing an outline. Maybe you see things in there like body, section, class, or div, lots of angle brackets. Slide 17. This is what technically we refer to as brackety stuff. Slide 18, or perhaps more technically as markup. Slide 19. This markup language has changed a bit since the early days of the web, but if you looked at the markup from a website from 1996, it would be remarkably similar to what you see today. Probably a lot simpler. Our markup style has gotten a bit verbose these days, but it wouldn't be like reading a completely different language. It wouldn't even be as like reading something like Old English. Markup is like the stable foundation of the web, and since the earliest days, this common markup has been the stable foundation of the web. Slide 20. In fact, it was in 1994, still in the very early days of the web, that the web standards body known as the W3C was formed. By 1996, they'd assumed standardization responsibilities for this markup language. And this standardization was important because of what the web was trying to do: connect information across the world between pages and documents that might not share any commonalities, but a common markup language. If they were going to connect successfully, it was because they shared this common language. The stability, consistency, and dependability of standardization helped the internet grow. Slide 21. And this common language, this markup language, has a very, to me, a very 90s name. It's like the hypertext markup language. Hypertext, a term that was actually coined in the 60s, essentially just means text connected by links. And this hypertext markup language is our common language of the web, HTML. And these days, most folks have heard of HTML. Slide 22. HTML is everywhere, except where you might expect it. With all the HTML lying just beneath every single website and service we visit, it may come as a surprise to learn that for the most part, most modern websites aren't typically written in HTML at all. Slide 23. And to understand why, it's worth thinking about something we talk about pretty often here at USWDS, and that's components. Slide 24. Components are a way to think about how websites are constructed from modular, remixable building blocks. These are things like headers and footers, buttons, cards, icons, date pickers, navigation, step indicators, breadcrumbs, search, etc. We see something of a simplified example of these on screen with components as like little squares with dotted line borders. Slide 25. These components are meant to be repeated and reused all across applications, across all kinds of different forms, pages, and workflows. Most of the stuff we see on any website or service is a component of some type. A wireframe for a web page or interaction flow, something like what we see on screen, can sometimes just be a way to see how components are used, how they're remixed and reassembled to create a coherent layout. Slide 26. For modern websites, anything that appears again and again like a component is a great candidate for a template, like a stamp or like a little printing press that outputs that component wherever it's needed with the proper content and data for just that instance, for just that button, just that form field, just that breadcrumb trail, or just that side navigation. Design this little component printing press once, like we see here with this square that's a step indicator. Design this little step indicator component printing press once and include it every time you need to output a step indicator or a component. So what does a template do? A template receives unique data and content as input and outputs the HTML the browser interprets. We see here on screen. We see data, logic, and content going in to the component template, and coming out of the component template is markup. Slide 28. So just as you can think of a page as made of components, like this component wireframe that we saw before, slide 29, it is perhaps more accurately made of component templates. Modern websites are built out of templates large and small. Component templates, section templates, page templates, interaction templates, workflow templates. Templates. Slide 30. And essentially, template languages allow applications to output HTML dynamically based on data and logic. You're not writing a bunch of HTML, you're writing logic and passing data and letting the machine take care of the repetitive hassle of writing all that HTML. Slide 31. If HTML is highly standardized, the world of templates and template languages is not so much. There are all kinds of template languages changing all the time. Developers might know a bunch of them, or they might only know one really well. Usually only use like one per project. While HTML evolves slowly, the product of a centralized international standards body, template languages follow the logic of the marketplace, finding new evolutionary niches based on new developer needs, individual passion, and a desire to build something new and better, or even just different. There are lots of different template languages, and there will always be more of them. Slide 32. So the web wouldn't exist without the standardized interoperability of a common HTML. Slide 33. But modern dynamic applications couldn't exist without template languages. Slide 34. Yet even while the hair of templating languages scurries this way and that, constantly whizzing back and forth, The tortoise of the standardized world of web technologies continues to plod ever forward. Slide 35. And about 10 years ago, in 2013, the web standards body responsible for HTML published the beginning of a way to integrate the power of component templates into the fundamental technology of markup by adding the ability to build custom additions to HTML. Slide 36. So to understand what this means, let's take a look at the building blocks of HTML, at HTML elements. Slide 37. The fundamental unit of HTML, of this markup language, is the element. And today, in the current living standard of HTML, there are a bit more than 100 of them, almost exactly as many as there are in the periodic table of the elements for the physical elements of chemistry. There are about 111 HTML elements, depending on how you count them, and there are about 118 physical elements. So I kind of set these elements up here on screen like a grid, a little bit like the periodic table of elements. And an element is simply a way to describe a part of a document, like a heading or an article or a paragraph, or a section or a general division. Elements give structure to documents. They describe a model of the content of a document. So if you look around at this grid of HTML elements on screen right now, and this isn't all of them, by the way, you may see a bunch of things that look familiar. Heading levels like H1 to H6, a table, form, input, and button, the paragraph, P, and perhaps what we might think of as like the hydrogen of the HTML elements. Slide 38. The anchor link, A, which we now see highlighted in the grid. A, it's a great element. It's arguably the element that made the web what it is. And we can use the A element to take a look at the parts of an element. Slide 39. So here's kind of what an element looks like in the wild, what it looks like in markup. Since most, but not all elements are designed to structure content, they're designed with like a two-part system, an opening tag at the beginning and a closing tag at the end that enclose some type of content. Opening tags and closing tags are surrounded by angle brackets. The closing tag uses a forward slash to indicate that it's a closing tag. And the opening tag can also include attributes or information about this specific instance of the element. In this case, the attribute for the A element is one that's pretty critical for any anchor link, the hyperlink reference to the destination address, otherwise known as an href, hyperlink reference. So for an anchor link, you really just need two things in this element. You need the text that serves as the link, in this case, USWDS, and you need the destination address for the link. You need that href equals a URL. I didn't write out a URL here, but it's like a website address. So in the end, you have a href equals something, and then the content of that element, and then the closing tag. And that's what this element encodes. That's the model for a hyperlink. Slide 40. On screen, this is kind of what we see by default. We see USWDS blue and underlined by default. If we select this link, our browser will take us to the address we specified in the element's href. If we hover over this link with a mouse, the cursor will change into a pointing finger to indicate that this element can be selected. We don't see the element's tags or any of the attributes exactly. What we see is the browser's interpretation of the element model with the content and data we specified. Slide 41. HTML elements are the starting point for modeling components. But what about when a component doesn't have an analogous element? Slide 42. Or when an element doesn't support all of the functionality that's required by a component. Slide 43. This is kind of when we have to build our own models. Slide 44. So to give an example of what this might mean, let's look at something like breadcrumb. Slide 45. Maybe you could imagine breadcrumb as being a standard HTML element. Wouldn't be a stretch, but it doesn't exist. So let's look at a few instances of a breadcrumb to try to identify its key aspects. On screen, we see 4 breadcrumbs of differing lengths. Each has a house icon at the beginning. Each has a little chevron-shaped separator between little bits of underlined text. Slide 46. And as we see highlighted on the screen, the first thing we might notice is that those bits of underlined text are links. A breadcrumb is a collection of links. Slide 47. At the start of each collection is a home, which is now highlighted on the screen. Slide 48. And at the end of each collection is the current page. It's also now highlighted on the screen. Slide 49. So this might be something of our content model. We've got a collection of links for our breadcrumb. The first is always a link to a common home. And then there can be any number of optional links in between. And then finally, a link to the current page. And if you had just this content, you'd have everything you need to build a breadcrumb. Slide 50. And if we want to express this in the language of standard HTML elements, we have to manually interpret the model into standard elements. This can be complicated, and there are all kinds of questions you need to answer in this interpretation process. But the slide here shows a bit of where we might land over in the gold markup area. It's not important, all the details of this markup, but we've defined the breadcrumb as a navigation element. We've defined the collection of links as an ordered list. And we've defined a class attribute for each element, so we can write styles that target each of these unique classes. Our model can be very simple. Complex interpretation doesn't require a complex model. Our model doesn't have to answer the questions we address in the interpretation. It only has to sufficiently describe the content. So from this relatively simple model, we've developed a fairly complex bit of markup. Slide 51. So this gets to kind of like, what does USWDS deliver? USWDS doesn't deliver models or interpreters. It delivers only the final stage in this process, the markup, what we might call a markup specification. Slide 52. So what do project teams do with what USWDS delivers with this specification? Slide 53. Well, teams have to kind of like reverse engineer our markup specification back into a model that they can use as a project component template. As we begin to see here on the screen, we see the USWDS specification starts to influence a project component template. Slide 54. And then once they have a template, they can pass their own project data into the template and use that template as an interpreter to output their own project-specific markup that matches the USWDS spec. Slide 55. And then what happens when USWDS updates the HTML spec? Well, teams have to go in and update their component templates. So we can see here, like the USWDS spec has changed. It's V2. It has a red burst on it to indicate that it's new. Slide 56. Well, when it's new, teams have to go in and identify what's changed in the new USWDS spec. Like what's changed between what we're saying now and what we said then? Like what do we need to change in our template to match this spec? Slide 57. So then they have to update their component template to make sure it's outputting markup that matches the new spec. And they have to do this every time USWDS makes a markup change. And accessibility related changes often have related markup changes. And key functionality changes often have related markup changes. And static content changes are often markup changes. There are a lot of things that can trigger a markup change. Slide 58. And so this is work. This is time, energy, and resources for the people who are maintaining these component templates for these model builders. And this is multiplied by every team that's using the design system. It's a lot of cascading friction, a lot of cascading effort. And you can see why not every team can keep up with our updates. Slide 59. And this means that it makes it hard for USWDS to change. We have to be really conservative about the types of changes we can make and when we can make them. The diversity of template languages has meant that we've never been able to support any of them directly, and we've been stuck delivering an HTML spec, even while we know that this isn't how teams actually build. Slide 60. But what if, instead of the HTML spec, we could deliver this model directly as some kind of custom element? Slide 61, along with an element interpreter to translate this custom element into standard HTML. Slide 62. Well, wouldn't that be pretty much exactly like what we've sort of described as a component template? And yes, it would. Slide 64. And that ability to define custom elements and element interpreters is what the HTML standard released in 2013. And after some time, that standard that they released is mature enough and the browser support is good enough that we can begin to use it. Slide 65. And this standard is the global web standard that we call web components. Slide 66. And as we started to see before, the power of web components is how we build our models. And the flexibility this allows our element interpreters to change and evolve the type of markup that they assemble. Slide 67. So we can return to our breadcrumb model and to the set of different breadcrumb instances that we use to develop that model. Here again, we see those 4 breadcrumb instances of different lengths. Slide 68. And we're looking again at our content model. And our content model can stay as it was. But now we want to investigate what it might mean to configure our breadcrumb. That is, if we think back to the HTML element model, are there any attributes we could imagine that would be like little knobs or switches for our element that might affect the way the breadcrumb looks or behaves? Slide 69. For example, maybe you should be able to change the font in the breadcrumb, like we see here, changing the font to a serif. Slide 70, or maybe you might want to change the icons, either for that home or for the separators. We see them highlighted on this slide. Slide 71, or maybe there should be an option to omit that house altogether. Slide 72. This is only the beginning of this type of discussion, but it begins to develop not only a content model for an element, but an attributes model as well. So attributes might include something like font or house icon, separator icon, has house, but there could be other kinds of configuration options as well. Slide 73. And a really powerful thing about defining models is that they can support all kinds of potential output and markup. This concise model defines not only a current state for the breadcrumb, as we see here with those breadcrumbs we've seen before. Slide 74. But it could also support potentially different presentations of breadcrumb as well. Now, I'm not saying that what we see on screen here is a good idea, like for longer breadcrumbs replacing the inner items with a drop-down menu. Probably a bad idea, but it's possible that there's something that's either better than the current state or becomes a user expectation for an interaction like breadcrumb. And our model describes this potential version of a breadcrumb just as well as the current version. And as long as breadcrumb stays conceptually as a collection of links that starts with home and ends with the current page, our model doesn't have to change. And the way we interface with our custom element doesn't need to change either. Slide 75. The power of the web component is the ability to have a simple, elegant model as expressed as a custom element that can be a consistent interface for a developer, even as the element interpreter can make changes under the hood. Slide 76. Because unlike a markup spec, developers can update element interpreters automatically. We're including only those items critical to the model as things that developers have to take care of. Under the hood, the interpreter can be updated automatically. Developers only have to care about the interface, only those elements of the model that need project-specific configuration. And when we're thinking about developing custom element interfaces, we really have 4 goals. We want to make them clear, we want to make them concise, we want to make them consistent, and we want to make them configurable. So we can take a look at a couple examples to get a sense of what I mean. Slide 78. On this slide, we get a look at what the custom element interface might look like for a breadcrumb web component. We want it to be clear and concise. This 5-link breadcrumb instance is only 6 lines long, focusing on the collection of anchor links unique to this instance. We see from the first line of code in the opening tag that this element is called USA breadcrumb, and it contains 4 unique anchor links. Well, why not the home link? Like a question could be like, why not the home link? Well, since the home link has the same text from instance to instance, we could leave that link out of the collection and only capture its URL or its address in the element properties with what we see up there as home equals URL. Why ask someone to write out the word home again and again if they don't have to? Though I will say, as an aside, it's a longer topic, but we do want to consider, multilingual needs in here as well. And we build in the ability to do that, like if you have to change some elements of the output language. But we also want to make the breadcrumb configurable. This example shows how you might add a configuration option to breadcrumb. Right here, there's an attribute called RDFA. And this configuration option could add special RDFA metadata to the breadcrumb to improve search results and findability. That's a lot of additional markup. But the interpreter could add that just by adding the RDFA attribute to the element. And finally, consistency. Since this custom element interface includes all the information the element interpreter needs to build all kinds of breadcrumbs, the custom elements interface doesn't need to change over time. Crucially, the interface can remain the same while the interpreter does all the heavy lifting. And that interpreter can be easily updated from version to version of the design system. In the end, you can see the difference between our new web component and its 6 lines that developers need to learn versus the 54 plus lines that developers need to track in our current markup spec. Slide 79. We'll just take a quick scroll through those 54 lines on the right side of the page. It's much longer. Slide 80. Yeah, really a lot longer. Slide 81. And all those extra lines are just more things for developers to track. Additional points of potential failure when building a website. It's not really important for us to know what this markup says here on the page. We don't have to read it and know that it's a LI property equals item list. Because we're just scanning through it here, because it's kind of not important to know it. It's something that a developer shouldn't really have to pay attention to either. It's just an additional point of failure when building a website. It's just an additional detail. These are details that developers shouldn't be required to track and understand. When it comes to web components, for developers, it's the interface. It's the 6 critical lines that we see on the left that are important, not all that final markup that we just sort of scrolled through almost without looking at it. Slide 82. Our government banner is another good example, perhaps an even more dramatic example than breadcrumb. It can be hard to stay up to date with the banner, since anytime we can make an improvement to the copy, it requires a manual update for a developer because that's a change to the markup. What if the banner wasn't 93 lines of markup to track and implement? What if it was closer to the clear, concise, configurable, and consistent 6 lines that we see on this slide? USA banner, domain equals gov, background equals dark, width equals widescreen, and then a close USA banner tag. So this custom element, USA banner, contains all the critical information a developer needs to set up and configure the banner. We can set the domain as gov, so the rendered banner shows copy that refers to .gov domains. We can set the background to dark, so it has a custom color. And we can use USWDS design tokens to set the width of the component to widescreen, so the text extends the same width as the rest of the elements on the site. And that's it. There could be more, but those are a few key important things that it needs to do. And those are really some of the most important things. And the element interpreter does the rest. And developers don't have to worry about 93 lines of custom markup and copy that's subject to change and evolution over time. That copy is important. What we have up there is important, but it shouldn't necessarily be a developer's responsibility to track those changes over time and continuously update their component templates to match the changes that USWDS makes. Slide 83. So for example, what if we wanted to display the Spanish version of the banner? Instead of copying all the Spanish language copy and metadata into a custom template, we could just maybe add a new attribute, lang equals ES, and the banner updates to Spanish with just a single line of code. Slide 84. Clear, concise, configurable, and consistent custom elements. The element interface stays consistent, slide 85, while the element interpreter handles changes under the hood. Slide 86. This makes the move to web components a big change in terms of upgradability and maintainability. When you're upgrading or when you're updating a web component, you're updating the interpreter, not the markup. And updating the interpreter, a little bit of code underneath, can be as simple as running a simple update script, essentially pushing a button. Hesitant to promise something like one button updates, but it's a lot closer to that than what we currently have. Slide 87. So anything handled by the interpreter can be updated automatically. Slide 88. And this can be things like markup, like logic, like accessibility support, like metadata, like static content, styling, and behaviors. Slide 89. And this means a move to thinking about theming as configuration, something that can happen closer to the custom element layer. Theming is more like input data to a component, rather than a layer of styling that's applied from an external style sheet. Though external style sheets are still related, as we move to web components, we're thinking about styling as data that is almost like an attribute of a component. Slide 90. So altogether, the custom elements and element interpreters model of web components combines the power, the continuity, and like the broad support of standards with the flexibility of templates and templating languages. It's a well-supported, cross-browser, platform-agnostic standard that takes the design system out of the static world of markup spec and into the dynamic world of templating. Slide 91. Making the design system easier to implement and easier to stay up to date. Slide 92. Because, and I think this is really pretty key, like maintenance and maintainability is just like the baseline. That's just like table stakes, not just for the design system, but for anyone who uses it. Like, what would you do if you weren't focused on maintenance? What higher order questions could you begin to solve? What mission and user-centered questions would you try to solve? Slide 93. Like, what could we do if we had the opportunity to focus on our shared mission, on shaping the future of government digital services? This technology is critical. It's necessary infrastructure. But the important question is what we're able to do with it. And that's a great question that I'm hoping we'll be able to ask again and again and again as we move forward.